Hi girls, welcome to a short video introduction on projectile motion. Hoping that you'll get to watch this and generate a little bit of your own understanding before we come to class and apply it in more depth to our gymnastics. What you need to make sure that you're learning is that you can describe how a projectile moves through the air, that you can identify the different forces acting on a projectile, to recognise the different factors affecting projectile motion and in particular the projectile's pathway, and of course to be able to apply this knowledge to gymnastics and particularly to our somersault skill. A projectile is any object that is released into the air. We don't include things that have their own method of propulsion, like an aeroplane, for example, but anything that is thrown, like a basketball or a football, anything is struck, like in tennis or cricket, or anything that involves the athlete's body itself moving through the air, like a long jumper, a high jumper, a skier doing tricks, and in our case, a gymnast. So as we've learned, a projectile always follows a similar pathway. It describes the shape of an upside down U, which we call, this shape is what we call the parabola. It makes this shape because of the forces acting on it. So the initial force that gives it its horizontal and vertical displacement, and then generally gravity. We also have other forces like impact, if the projectile hits into anything, like another tennis racket, for example, and air resistance, but we're going to be ignoring talking about those because they don't really apply to us when we're looking at gymnastics at this stage. So there's a couple of things I want you to do. I want you to pause the video and just trace the shape of the parabola in each of the two pictures. Now I want you to think about what would a parabola of a high jumper look like, and how would it be different to the example that we've got here of a long jumper. I'll be asking for that one in class tomorrow. So we know that a parabola, or the pathway of a projectile, is the combination of both horizontal and vertical displacement. The amount of vertical and horizontal displacement and the relationship between those two actually depends on what the goal of the activity is. So for example, if you think of a basketball player shooting from underneath the basket, we'll see a parabola with lots of vertical displacement and not a lot of horizontal. However, if we look at a basketballer shooting a three-pointer from a lot further away, we'll see a lot more horizontal displacement in that parabola than vertical, so a much flatter looking parabola in that case. There are three main factors that affect projectile motion. One is the speed of the release. So the speed of release depends on the amount of force that is applied to the object as it is released, the angle of release, and the height of release. Those are the three key ones. Also, air resistance, spin, and impact can all affect projectile motion, but again, as I said, it's not really relevant to what we're looking at in the context of gymnastics. So which of these three do you think that would be most important in our somersault from the mini tramp, out of speed of release, angle of release, and height of release? And can you tell me why? Generally, the greater the speed of release, the greater the range of that projectile, so the further it will go. Speed of release generally has a much bigger influence on the range of the projectile than angle or height of release. And in gymnastics, the speed of the gymnast is more important than gaining a maximum distance. So we're not trying to jump the furthest, where actually our speed in general is important for a lot of vertical displacement as well as time in the air. The angle of release is not quite as important. What we do here is we find that if the angle of release is too high, we don't actually travel far enough in the horizontal direction. This could be potentially quite dangerous if we don't travel far enough horizontally to actually reach the landing mat. So for example, if we went straight up on a mini tramp and then came back down and landed there as well. However, if the angle of release is too low, then we don't get enough vertical displacement, which means we're not going to have enough time in the air to complete our rotations. So how can we change the angle of release in this particular skill of doing a run up onto the mini tramp and completing a somersault? If we keep speed and angle of release the same, what we find is as the height of release increases, the horizontal range increases as well. This is why we have a taller basketball player who is able to shoot from further away, given the same speed and angle of release. Because he is much taller, he can still, where he releases the ball from, he can still cover that same horizontal range. So girls, I hope that little introduction has been helpful in looking at the key points, but also fulfilling these learning intentions. If any of these still don't make sense, then I encourage you to do a little bit of extra work to clarify your thinking, and then we can discuss in class over the next few days. Thanks very much.